everyone, it's Tara. Welcome to the channel. I'm about to play another TryHackMe room in the Attacking and Defending AWS learning path. This next room up is an IAM room focused on resource policies and service control policies. So I'm excited to keep going. Hopefully you've been enjoying the videos so far, and let's get started with the next room. So this is the Resource Policies and SCPs room. SCPs stands for Service Control Policies, which are attached to accounts in AWS organizations. And this room already has 9 likes, which I think maybe is the most I have seen in this learning path. So maybe it's going to be particularly good. Let's go check it out. The first task is called Other Policy Types. While 80% of the time when working with AWS, you'll be using IAM policies, there are 2 other types of policies you need to know about. They use the same statement structure as an IAM policy, but are attached to resources or accounts to affect how access is authorized. You all should have heard the way I just tried to pronounce authorized a minute ago. All right, so this is just an introduction to the room. We don't need to solve anything or answer a question. We just hit completed to move on. And then task 2 is about accessing the environment. We've gone over this a couple of times now. So we know we need to scroll to the top of the room, check out the cloud details. Looks like we don't have anything we need to generate here, so we should be good to go. Our environment is active. Let's see. Oh, and now that I'm thinking through it, and with the environment state being active, probably the reason we aren't seeing this generate button down here is because when we press generate in the IAM principles room, it generated everything we need for this whole module. Okay, that makes sense. All right, so scroll back down. And let me just verify at the command line that I still have my profile configured. So let's see. Yep, awesome. So I see my TryHackMe bucket, so I know I'm still good there. So I'm going to hit completed because I am good to go on environment configuration. And let's move on to task 3, which is really almost like the task 1 of this room, but okay. Task 3 is about resource policies. So we learned about IAM principles, we learned about IAM permissions. Now we're going to learn about resource policies. IAM policies are attached to a specific principal and define the resources that the principal can act on, whereas resource policies are attached to a resource and define the principals that can act on the resource. So far, what we have been seeing for the most part has been IAM policies, which are attached to the who of IAM, like the user or the role, and then they give that principal permissions, whereas resource policies are attached to the resource itself and then define different principals that can use the resource. And probably like the most common example of this, and I see it's first on their list here too, is S3 storage buckets. So it's very common that you'll see an S3 bucket has a resource-based policy attached to the bucket, and then that policy says this is who's allowed to access this bucket. And this is what's used to create what's called public S3 buckets, which are very frequently used for website hosting or hosting assets for websites. And you can make a bucket public by attaching a resource policy to it that just allows anyone to have access to that bucket. So that would be an example versus attaching to thousands of different users a permission policy that says they can access this bucket. Instead, we can attach one policy to the bucket that says everyone can access it. Think carefully before you do that specific thing, but that's one example of what a resource policy is. And other AWS resources that can have resource-based policies attached to them are KMS keys, so that's key management service encryption keys, SQS queues, simple notification service topics, AWS Lambda functions, secret manager secrets, and IAM roles. So yes, an assume role trust policy, like we've seen before, is an example of a resource-based policy because we attach it to the role, and the assume role trust policy says, here's who's allowed to use this role, here's who's allowed to come check out this role and create a session with it. The command to apply a resource policy varies based on the service. S3 buckets are one of the most common use cases for resource policies. For demonstration purposes, we've created a public S3 bucket in another TryHackMe account. That bucket is creatively named TryHackMe Public Bucket. That is very lovely and creative. And this is a good opportunity for a reminder. So remember, if you're newer to AWS, that S3 bucket names have to be unique globally. So now that we know that TryHackMe has already made a bucket called TryHackMe Public Bucket, none of us can make a S3 bucket called TryHackMe Public Bucket. Remember that S3 bucket names are unique identifiers within AWS. And the bucket policy for the bucket is as follows. So it looks like this is a resource-based policy. We can tell that right away, even if we didn't know from the TryHackMe narrative, because we can see there's a principle in it. So that would indicate it's a resource-based policy. And The juicy part here is the statements. We've got two statements here as part of the policies. The first one is called make object readable, and the effect here is allow. The principal is everyone, so this is what makes it a public S3 bucket. The action is get object, and then this part is very important. The resource, the get object applies to every single object in this S3 bucket. And the way we can see that is because this is the S3 bucket itself. And then this /* this wildcard, is saying every single object in the bucket. This one means this would match every single object key that is possibly stored in this bucket. And then the second part of the policy, the statement ID, is make bucket attributed world. I think maybe that's supposed to say make bucket attributes world readable. And the effect is allow. The principal, once again, is everyone. And the action is get. And the action is get *. So this would be any of the get actions in S3, like read actions. And then S3 list bucket, which would allow you to list all the objects that are in the bucket. And the resource is the TryHackMe public bucket itself. And there's a very key distinction here between these two examples of resources in a policy. So this resource clause gives permission for the S3 bucket, but would not give you any permission to access the objects in the bucket. This resource is necessary to give permission to access the objects within the bucket itself. And let me tell you that if you are studying for any AWS certification exams ever, this is a very common question that I've seen on AWS certification exams. I've probably seen it like 4 or 5 times on live exams that I've taken, and then practice exams, I've seen it tons of times. To have an S3 bucket be truly public, you have to give permission to objects in the bucket. You need to have something here that's saying what objects in the bucket that the principal can access. If you just have the bucket name like this, you're giving permission for the bucket itself to learn things about that bucket, but you'll never be able to get any objects out of it. So keep that in mind if you're trying to pass an AWS certification. That's like a common gotcha here, is you need to give permission to the objects in the bucket. It's not satisfactory to just give permission to the bucket itself. And it looks like this is probably just saying the same thing in a more condensed manner. But in the case of S3, there are 2 AWS resources involved, the bucket and the objects in the bucket. The first statement allows anyone, so that's the principal * we talked about, to get object on all the objects in the bucket. And the second statement applies only to the bucket itself. And that's indicated by the bucket name here, and allows anyone to get the attributes of the bucket, which is the S3 get *. And that that wildcard will match different things like get bucket policy, get like bucket object versioning. I can't list them well off the top of my head, but there's a bunch of different attributes that are accessed with the S3 get API action, and that wildcard will match all of them. And then to list the objects in the bucket, we have S3 list bucket. So we can give it a try. Run this command from your attack box or Cloud Shell session. So always obstinate, always the rebel. I am actually not going to bother to spin up the attack box or Cloud Shell, and I'm just going to do these commands locally. And if you watch some of my other AWS Room walkthroughs, then you might remember the reason I can do this is because I have configured a profile for the AWS CLI locally with my TryHackMe user credentials. What I'm going to do is run all these AWS commands using that profile. So I'm going to do AWS default profile. So for my little session here, I'm going to make my default profile TryHackMe, which is the profile I created earlier. And if you wanted to see how I did that, you can go back and watch some of the earlier AWS Room walkthroughs. And if I have time, I'll maybe write some instructions as well and link them below. Okay, and even though I went ahead and set up my profile there, I actually don't think we would need that specific profile to run this command, because it looks like we're going to run AWS S3 API get bucket policy status, and then the bucket, we're going to target the TryHackMe public bucket. And why we are going to be able to do this is irrelevant to the TryHackMe profile. Anybody should be able to run this command and get a response, because this resource policy, right, allows all of these get actions on this bucket to anyone. So let's go ahead and run this command. So satisfying when you run a command and you get the output on the first time. So let's see, policy status, it is a public bucket, so they weren't lying to us, so that's good. So there's that. And then we can try and list the files in the bucket. And remember, the reason we'll be able to list the files in the bucket is because we have this S3 list bucket permission. Anyone in the world can do this S3 list bucket API call. So let's do that. All right, so it looks like we have one object in the bucket, which is a PNG file, an image called My God Full of Stars. So now you know, of course, we have to see what this image is, even though I wonder that's probably what we're gonna be doing later on in the Try Hack Me room as well. But I can't wait. I'm nosy as hell, so I have to know now what this image is. So let's do make dir S3 object and CD S3 object. And again, I'm going rogue here. This is not part of the Try Hack Me lab. I literally just want to see uh, what this picture is. So we can get that picture down from S3 because remember, anybody in the world has permission to get the object. We can run AWS S3 copy, and then I think we can do it in either order. So we can do S3. I'm forgetting exactly how you do this. S3, and then TryHackMe public bucket. So that's the public name, or that's the bucket name. And then we need the object key, which we know from our list objects command. So that should be the object in S3. And then let's just copy it right here to our local directory. And let's see if I got that right. Okay, brilliant. So now we can do open, and let me all right. And I'm sure this is like a reference that everybody watching this gets that I just am not cool enough to get. But that is the image that's in that public S3 bucket. Very fun, very nice. Let's get back to what we're actually supposed to be doing in this lab here. So resource policy. So we were just learning about a resource policy applied to an S3 bucket to make it a public bucket. And resource policies can also be applied to control whom can invoke a Lambda function. So we're going to cover Lambda in a future module. Big fan of Lambda, but we can learn about it now. So we're going to try executing this Lambda function and then look at the output. All right, cool. So let me clear up this. Clean that up. And real quick, I'm pausing the walkthrough because I added a quick pro tip on the screen here after I was done recording. If you want to run these commands locally like I am, make sure you have JQ installed, and you can install it using the link on the screen. All right, so let's go ahead and try and invoke this Lambda function. So we've got AWS Lambda invoke, and looks like the function name is TryHackMeTime. So we'll invoke that from the CLI. And the status code, we got returned to 200 status code, which should mean we successfully invoked the function and got a response. So that would indicate that whatever resource-based policy is attached to this Lambda function, we do indeed have permission to invoke it. And let's try looking at the policy for the Lambda function. So this is the resource-based policy attached to the Lambda function, and looks like, and they gave us the example command so we could even get the policy right now ourselves. Very nice. Okay. So it looks like this is a policy that has two statements. First of all, we have one statement that has an effect of allow for anybody to get the Lambda policy, which is that command we just ran, AWS Lambda get policy. So we have permission to get that policy, and looks like anyone in the world can get that policy on that Lambda. Then to invoke the Lambda function, the reason why we were able to do that is because we have this second statement that says effect allow anybody to invoke the Lambda function on this TryHackMeTime Lambda function if, and then here we have a condition, so that's a little bit different. Here we have a condition that says if your account is part of an AWS organization and the organization ID is this. So our TryHackMe account is part of this AWS principal organization, and that is why this condition evaluates to true and we're able to invoke the Lambda function. But if we were to try to invoke the Lambda function from an account outside of these TryHackMe accounts that are part of this organization, then we wouldn't have permission to do that. So that's an example of how they're using a condition in a resource policy as well. So we can see the resource policy for this function allows anyone to run Lambda get policy. Anyone in the whole world can run Lambda get policy, and all members of this specific AWS organization can run Lambda invoke function. That's a very good example. I like that. I like the way that they formatted that. Okay, and now to the fun part, and now to the extra juicy part, the questions. Let's see what they got for us. Try running the S3 API command get bucket ownership controls against the TryHackMe public bucket. What is the object ownership value set to? So we should be able to do AWS S3 API, and then looks like the command is get bucket ownership and control. Let's just do copy, and then I think it needs the flag like this, TAC bucket, and then we want the TryHackMe public bucket, and let's see if I got this right. Okay, awesome. So it says object ownership, bucket owner preferred. Let's see if that's correct. I think it is. All right, cool. So for object ownership in that TryHackMe public bucket, the object ownership is set to bucket owner preferred. And then try invoking the Lambda function TryHackMe quote in the same account. What's the quote returned from the function? So same account I'm thinking is referring to when we invoked this other function a minute ago. So we could probably reuse most of this command. So let's just paste that. I guess I could have just scrolled up in my history, but I didn't think of it till right that moment. Try invoking the Lambda function TryHackMe quote. So they're telling us here that try invoking the Lambda function TryHackMe quote in the same account. What's the quote returned from the function? So when we target a Lambda function with this command, the function name argument here, we're sending the arn of the Lambda function as the argument. And you might remember from an earlier room that the arn always has the same format. It's just certain values that are changing. So for example, this part of the arn is the region, and it doesn't say this, but I guess we're just going to have to presume for now for our first try that the new Lambda function is in the same region. And then they did tell us it's the same account. So that part stays the same. This part that says function stays the same. The only thing that needs to change is the function name in the arn. So they told us that the one we want to target now, instead of time, we want quote. And I think if my memory serves me correctly, what's going on here is that we're saving the output to a file, and then we're catting that file. So let's just change the name to be accurate here, and then we'll make the response a little bit more parsable. So let's see if we got this right and if we can invoke this other Lambda function. We successfully invoked the Lambda function and got that 200 status code back. And let's see what kind of output we got. All right. What's the quote returned from the function? So the Lambda function returned most heard comment at reInvent. Dude, Lambda is the coolest shit ever. Werner Vogel's 2014, which I think 2014 was pretty close to the first reInvent, if not the first reInvent. I'm not 100% sure about that. Maybe I'll look it up later so that I won't be spreading fake news on my video. But anyway, let's see. So we want the quote is our flag, and most heard comment at reInvent. So it starts with the 4. What's the quote? All right, so let's see if it wants. So we know it starts with a 4-letter word and then a 5-letter word, which is like most heard. And it says, what's the quote? So let's try this, perhaps. Oh, but it could be this, dude. Oh, but there's no comma. So let's try the whole thing. And let's see if that's correct. Oof. All right. Boo. Wah wah. No. Most heard comment. Let's delete this so we can see our little input guide here. Most heard comment at. I think maybe part of what's happening here is this gets cut off, so we can't see the whole thing. So I'm just going to try giving it the entire output instead of just the quote. And if you don't know who Werner Vogels is, he is the CTO of Amazon, and he's speaks at reInvent a lot and really smart and very iconic and famous. So this is his quote, and he must have heard a lot of people saying Lambda is the coolest shit ever, which is very cool. I agree with that. All right, so let's post the whole thing, even though this is so bothersome because look at this. There's no quote at the beginning. There is a quote at the end. If this is right, but we got it. That's what they wanted. And now we'll move on to task 4, which is about service control policies. Service control policies are associated with AWS organizations, or are a function of AWS organizations is what it says here. So when you hear SCPs or service control policies, think AWS organizations. They exist outside of your AWS account, and then they're applied by the parent organization's management account. If your account is a member of an AWS organization like ours is, we saw earlier with the Lambda resource policy, then you might have a service control policy or more than one service control policy applied to your account via that organization. And a service control policy is applied to every principal in the account. So every user, every role, every IAM principal in the account, including the root user. So this is the only way you could have limitations of the permissions of a root user in an AWS account is if that AWS account is part of an AWS organization, the root user could have an SCP that restricts the root user permissions. Service control policies are typically leveraged by enterprise security or compliance teams to ensure that the corporate directives for cloud usage bind to even account administrators across an AWS organization. Again, just getting across that point of this is a way that you would put restrictions even on administrators in an account is to use service control policies and to enforce the same standards on every principal in the account. Service control policies could be, for example, configured to prevent disabling CloudTrail, which is the AWS auditing service. You don't want anybody to be able to turn off CloudTrail in any account in the organization. You could use a service control policy to apply that restriction. Another use case they give as an example here is you could use service control policies to prevent using AWS services that a legal department has not yet vetted. So you could have a service control policy at the root of your organization that only approves certain services to be used in the organization and then wait until legal has vetted a new service to add it to the service control policy. So it's again just like that control at scale, that enforcement of rules and permissions at scale. Then there's one more example. They could also limit actions to specific roles. For example, only the global network administrator role in an organization would be the only person, would be the only IAM principal allowed to manage VPC route tables, which is a good example. Users in an AWS account cannot view the service control policies applied to the account. If you're just the meager peasant account in the organization, there's no way for you to see what service control policies are applied to your account. Until recently, AWS didn't even tell a user that was denied an action if an SCP was the reason that action was denied. So they must have just got like a generic access denied type error. However, some AWS error messages will now indicate if an SCP denied an action. Okay, cool. I didn't know that. Here is our question for task 4. This is like short and sweet. What are the last 4 words of the error message you get when you attempt to disable guard duty with this command? All right, cool. So they gave us an example command here, and I imagine this is probably an action by design that our service control policy on our organization in TryHackMe doesn't let us do. So the command here is AWS guard duty delete detector and then detector ID. And then there's a nested command here. So the nested command is AWS guard duty list detectors, query detector IDs, output text. So we're going to get the output of the list detectors ID, which is going to be the ID we're going to give as an argument for our delete detector command, which is all probably irrelevant because it's, I don't think, going to work. But if you're curious, that's what's going on in this command. And let's see what we get. All right, so we got an error occurred, access denied exception when calling the delete detector operation. And this would be like, I would say, a pretty generic error message in AWS. So I think that's maybe what was being referred to with the like until recently, AWS didn't even tell a user that was denied an action if it was an SCP. They just saw maybe something generic like this. And then the part that gets more specific is that our user is not authorized to perform delete detector on this guard duty resource. And the reason why is because there's an explicit deny. And where that explicit deny is in the service control policy. So let's see, what was the last 4 words with an explicit deny? So again, just emphasizing that service control policy is applied to that whole organization or a unit within the organization. And because our account is part of that organization or organizational unit, we have an explicit deny in this service control policy that is overruling any allow we might have anywhere else. All right, so let's see. With an explicit deny, I think is the flag here. Let's hit submit. All right, and that was the correct answer. So now we can move on to task 5, which is the summary task. And this is just wrapping up the room for us and says, now that you know about IAM principles, how a policy is formed, and how service control policies and resource policies interact, Let's dive into how authentication works in AWS in the next room, which is going to be focused on IAM credentials. I'm overall having a lot of fun with this, if you couldn't tell. And I thought that SCP and resource policy room was quite good. I like the way they presented that information. To wrap up task 5, we just need to answer the question below, but there is no question. Talk to me about AWS credentials. They're just getting us hyped up for the next room. So we could hit completed, and that completes the resource policies and service control policies focused room. And I'm excited to dive into this IAM credentials room probably tomorrow. Thank you so much for watching. I hope you enjoyed it. And I look forward to seeing you in the next Attacking and Defending AWS room walkthrough.